Hello, welcome to your geometry recorded session of the week. We are in the week of November 10th, and that means we're in week 13. So when you go to do this week's assignments, make sure you're looking for those folders marked week 13. I do have a warm-up problem that I'd like to start with, and I'd like you to do that in your math notebook. So make sure at this time that you've got your math notebook out in front of you and you're ready to take good notes. Remember, to get the most out of this, you need to be taking good notes. Make this worth your time so that when you go to do the assignments for this week, you'll have good notes from this recorded session that will really help you complete this week's assignments. So taking a look at the warm-up question, the figure on the right is a parallelogram. So I'm going to tell you it is a parallelogram. Based on the fact that it is a parallelogram, I want you to solve for y. I want you to solve for y. So go ahead and click pause and solve this problem on your own, and then when you're ready to check your work with mine, go ahead and click play again. Alrighty, so to solve this problem, first let's think about what we learned about parallelograms. What do we know about parallelograms that are going to help us solve this problem? So we know that parallelograms have opposite sides that are parallel. Will that help us solve this problem? So remember, those little squares will tell us that opposite sides are parallel. No, that's not going to help us. What about the fact that we know that opposite sides are congruent? That's going to help us. Opposite sides are congruent. That is one of the properties of parallelograms. So knowing that the opposite sides are congruent, we know that this side here that I'm highlighted in yellow is congruent to the opposite side. And both those sides have the variable y within the equation. So what we can do is just simply write the two equations and set them equal to one another. And then we're just going to solve for y. We're going to use our algebra skills. We've got variables on both sides of the equation, so what I'm going to do is I'm going to work on getting all the y variable terms on one side of the equation and all the constants, that's our whole numbers, on the other side. So I'm going to start by subtracting 2y from each side. When I do that, I'm left with 7 on the left. 4y minus 2y is 2y, and I've still got that negative 3. So we need to add 3 to both sides now so that we can work on getting that y all alone, and now we've got 10 equals 2y. We're almost done. 10 equals 2y. Our last step is to divide each side by 2. And we get 5 equals y, and that's our final answer. So when we plug in 5 for y, we should get, when we plug that into the equation, we should get the same number. So 5 times 4 is 20. 20 minus 3 is 17. So the side opposite should also be 17. 2 times 5 is 10. 10 plus 7 is 17. So we know we did that right. All right, so let's go ahead and move on. We got our head back in thinking about quadrilaterals, right? So in this unit 3, we are working on quadrilaterals, and last week we focused on a special type of quadrilateral, which is the parallelogram. So we are finishing up Unit 3 this week. We're going to do the last 3 sessions in Unit 3 this week, which means next week the Unit 3 test is coming your way. So I just wanted to give you guys a heads up of where we're at and where we're heading. So finishing up Unit 3 this week, and then it won't be assigned until next week, that Unit 3 test, but just a heads up, it is coming. Make sure you're working on missing work if you have any missing work. And guess what? Since we are in we're week 13, that means that there's only 5 weeks left in the semester. So we do have a week off for Thanksgiving break, and then we come back. So really we've got what do we have? We've got this week and next week, our full weeks. And then that following week, that last week in November is Thanksgiving. Then we come back from Thanksgiving break and we're already in December. And that means then that we have the first 3 weeks in December. So we're 5 weeks away from the end of the semester. So just wanted to let you guys know that so that you're aware of where you're at now and you're making some goals of where you want to be at the end of the semester and giving yourself ample time to reach those goals. Alrighty. Also, just a friendly reminder to make sure you're answering the questions asked. A lot of times you are asked to go beyond just finding the solution of a variable, but you're asked to find an angle or the side length, where then you need to plug that solution to that variable into a side length or angle. And most of you are doing a great job with that, but just to make sure you're reading the problems carefully and that you're answering what the questions ask. Alrighty, let's start talking about quadrilaterals. That's what we're here for this unit 3. So a quadrilateral we know is anything with 4 sides. And then last week we learned about a specific type of quadrilateral, which is a parallelogram. And remember, a parallelogram has opposite sides that are parallel, opposite sides that are congruent. We learned about the angles that we call them consecutive angles, or angles next to one another will add up to 180 degrees. And then we learned about the diagonals. The diagonals will bisect one another, so they'll break up into 2 equal segments. So this week we are going to learn about some special types of parallelograms. So we're going to learn about rectangles, rhombuses, and squares, and that's in Unit 2, Session 6, and I believe it's also in Session 7. So these new types of quadrilaterals that you're going to be learning about are special types of parallelograms. So see how we've got arrows pointing from parallelograms to the rhombus and then the square? So what I want you to take away is that rectangles, rhombuses, and squares are parallelograms because they have all the properties of parallelograms. So if you look, all of them have sets of parallel sides. The opposite sides are parallel to one another. Opposite sides are parallel. Opposite sides are also congruent, so the opposite sides will be congruent. And then the consecutive angles will add up to 180. Rhombuses, rectangles, and squares have all those properties. But then we get into more specific properties to make each type of these quadrilaterals special. So rhombuses will have all sides will be congruent, but their angles are not right angles, because some of you might be thinking, well, a square has all sides that are congruent. So what makes a square different from a rhombus? And that's the angles. So in a square, all sides and all angles will be congruent, where in a rhombus, not all angles need to be congruent. Now a rectangle has some characteristics of a square, right? All angles are right angles, but not all sides need to be congruent. So you can see that there's some similarities amongst these 3 types of special parallelograms, but keep in mind that all of these will have the characteristics of parallelograms. And that's really what I was, this slide reinforces that rhombuses, rectangles, and squares are all special types of parallelograms. They're going to have the same characteristics and properties of parallelograms, and then some more specifics. And here we go. There's this slide here is really great because it shows all the specifics about the special types of parallelograms, the rectangles, rhombuses, and squares. I remember I added in Unit 3 a folder with some great links to websites that explain all the different properties, because we're learning lots of different properties. So those websites are cool because they have all those properties in one place. So remember, here's our 4 properties of parallelograms that I've already went over. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect one another. So if you look here, it will say for a rhombus, the rhombus has properties 1 through 4 above, because it technically is a parallelogram. It's a type of parallelogram. What makes it different is that the diagonals are perpendicular to one another, so they're going to form a right angle in there. Right angle, drawing that in. And then the diagonals bisect the opposite angles. So I'm trying to say here is that the diagonals bisect the vertexes. So they're going to break them into 2 equal parts. And you can read about each of these rectangles, what the characteristics are, and then what the characteristics are of a square. And you're going to learn about all those some more in addition to what we're going over. It's all in the slides this week. Let's have some practice with rectangles and use the properties that we just learned about rectangles. So remember, let's review. So rectangles, we know they have all the same properties of a parallelogram, and in addition, we're told that the diagonals are going to be congruent. The diagonals are going to be congruent, and all the angles are also going to be congruent. They're all going to be congruent, all the angles. So let's review and see, or now let's see if we can put this to use, the properties we just learned. So the question says, how long is MO? So that's a diagonal, MO, and MZ, how long? So MZ is from the vertex halfway. So how long are those segments? So remember, we just learned that diagonals are congruent. We just learned that diagonals of rectangles are congruent. So we learned that the diagonals of rectangles are congruent. So we've got all these properties that we're learning that helps us solve these problems. So we are given that the length of NL, so NL is 26. So if NL is 26, what must NO be? MO. Well, the diagonals are congruent, so that means MO has to be equal to NL. So that means that if NL is 26, that MO must also be 26. So MO equals 26 units. What else did we learn? We learned that we know that diagonals bisect one another. We know that the diagonals bisect one another. So the diagonals are going to be, each piece is going to be congruent. So if MO is 26, then half of 26 is going to give us the length of MZ. So 26 divided by 2 is 13, so the length of MZ is 13. So we know we were able to solve that by using the properties that we've learned about both parallelograms and rectangles. So moving on, let's keep going here. Let's go to now trapezoids. So as you move on to Unit 2, Session 8, Unit 6, yes, 8, you're going to be learning about kites and trapezoids. So kites and trapezoids are also types of quadrilaterals. They are not types of parallelograms. So a trapezoid is not a type of parallelogram. So just a heads up, it's not a parallelogram. What is it? So a trapezoid is a type of quadrilateral, and it has exactly one pair of opposite sides that are parallel. So it's different than a parallelogram, because a parallelogram, all opposite sides had to be parallel. Where here, only one set needs to be parallel. And then we've got a special type of trapezoid, an isosceles trapezoid, where it's a trapezoid that has congruent legs, so it's going to have a set of congruent legs, and that will make it an isosceles triangle. So here's our set of congruent legs, and then we also have our set of parallel sides, which makes it one set of parallel sides makes it a trapezoid. What else about trapezoids? So if a trapezoid is isosceles, then each pair of the base angles is congruent. That's similar to that isosceles triangle theorem. So this angle here is going to be congruent to that angle, and then our pairs on the opposite sides will be congruent. It shares a characteristic of parallelograms in that adjacent angles are also supplementary. So our adjacent angles will add up to 180, just like parallelograms. So let's keep going here and let's see if we can solve a problem now based on what we've learned about isosceles trapezoids. So here we go. This quadrilateral is an isosceles trapezoid because we've got two sets right here, or one set of congruent sides and then our parallel sides that are opposite one another, making it an isosceles trapezoid. We are given one of our angles. Angle S is 50, and we need to find some missing other angle measurements. We want to find all the other angles. Can we do that? Sure. So let's see if you guys can figure that out. Is there another angle that you can figure out what the measurement would be? So remember, just like isosceles triangles, the base angles are going to be the same. So that means that angle R would also be 50 degrees. And then what else did we learn to help us find angle Q and P? We learned that the adjacent angles are going to be supplementary. So to find, let's say, angle P, we know that if we add that to 50, it has to add up to 180 degrees. Subtract 50 from both sides. Whoops, that is a messy 50. 180 minus 50 is 130. So we know that the measurement of angle P would have to be 130. If P is 130, that means Q has to be 130. So we found all of our missing angle measurements using the properties that we've learned about isosceles trapezoids. All right, another property of trapezoids is that the diagonals are going to be congruent. The diagonals are going to be congruent. So what that means is that AC will be equal to the length of BD. Their diagonals are congruent. Our diagonals are congruent. And that's for isosceles triangles. That's isosceles, by the way. Make sure that it's not for all types of trapezoids, specifically isosceles triangles. So if you can prove that the diagonals are congruent, then you've proved that you're working with a trapezoid, an isosceles trapezoid. All right, so let's do one example. Let's just do number 1 here. We're given the length of JN. So JN is 10.6. NL is 14.8. So I'm trying to write those in there for us. We need to find KM. Well, we know that the length of JL has to be equal to the length of K. Because we know this is an isosceles trapezoid based on two sides being congruent. These two sides here are congruent, and then we have that set of parallel sides, opposite sides. So we know this is an isosceles trapezoid, therefore we know that the diagonals are congruent to one another. And we know that JL equals 10.6 plus 14.5, and that's going to be the length of KM. So we just need to add those side lengths together, or those diagonals together. 10.6 plus 14.5, we get 25.1, and that equals the length of KM, not LMKM. So we're going to skip that second problem and move on to this next one. Trapezoids, I want to get into the mid-segment of trapezoid theorem. So remember we talked about the mid-segment of triangles. So we also have the mid-segment of a trapezoid. And it's the same thing as it is for triangles, where the length of your mid-segment is half well, it's a little bit different here. Instead of being half of the base, it's now going to be half of the average of your two bases. So it's a little bit different because now the mid-segment is half of the average of your two bases. So that would mean that the length of MN is going to equal 1/2 the average. So we're going to add the base, the top base, BC, the length of BC plus the length of AD, take half of that, and that will be the length of your mid-segment. Make sure you copy this down. You're going to need it. So if you need pause, go ahead and click it because I'm going to move on to the next slide. So here we go. Let's apply that. Here we've got a yummy looking layer cake, and we are told that the top layer has a diameter, so remember diameter is the length of the entire circle, is going to be 8 inches. The bottom layer has a diameter of 20 inches. We want to find out what is the length of the middle layer. So how are we going to do that? Go ahead and try this in your math notebook now, and then you can go ahead and click play to check your work with mine. So the middle layer, I'm going to put M for the middle layer, is going to equal 1/2. We have to add the top layer plus the bottom layer and divide it by 2. So really we're taking half of 28. And what is half of 28? 14. So that middle layer would need to be 14 inches. The middle layer, it needs to be 14 inches. That's a big cake. Alrighty. Kites. I did want to go over kites, the last thing, really quickly, and then we're going to stop for today. Kites are our last type of quadrilateral we're going to be learning about. And kites look like the type of kite that you can fly into the sky when it's windy out. So a kite is going to have two pairs of adjacent sides that are equal. So here, these two adjacent sides will be equal, and then these two sides are adjacent. Those sides will be equal. The angles are equal where the sides meet, so the non-vertex angles the angles are equal where the sides meet. So here, these two will be equal. And then the diagonals meet at right angles, so you can see where the diagonals meet. That forms the right angles. They're going to bisect, the diagonals will bisect each other, and then they'll bisect the angles. So there's really one set of bisecting diagonals, and that's, probably should do that with those two sides are bisecting. All right, so you'll learn more about kites this week. I did run out of time to go over exactly some more detail about kites. I don't want to make this too long of a recording. So we're going to wrap that up here, and that means we're ready for the key phrase assignment for the week of, oops, not 11, that's 11/10. Ugh, I read that backwards. November 10th. So we are in the week of November 10th, and that's the key phrase that we are going to complete. And the question is what is the difference between a trapezoid and a parallelogram? So tell me the difference between a trapezoid and a parallelogram. And that's it. So let me know if you need any help as you work through this week's assignments. And I'm going to go ahead and stop the recording. Have a wonderful rest of your week.